Day 282 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem. This time we're at day 282, and we're still going strong of doing daily LeetCode problems. Today we have question number 50, power of xn. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand. So let's see what the question says. Question says implement power of xn, which calculates x raised to the power n, i.e. x to the nth power. So let's go ahead and look at these examples. Even though it sounds simple enough, we're going to go through the examples just to make sure we know what it is exactly that they're asking us to do. So in example 1, we have the input x equals 2, n equals 10, the output equals 1024. So the output is 1024 because 2 to the 10th power will give us 1024. Y'all, it's that simple. We're just taking x and putting it to the nth power. So let's go ahead and look at example 2 just to really bring it home if they try to throw some decimals in there. So in example 2, we have x equals 2.1. This time n equals 3. So we want 2.1 to the third power, which is going to give us our output of 9.261. Now let's go ahead and look at example 3 where they might try to throw another trick our way by giving us a negative integer for our exponent. So in example 3 we have x equals 2, n equals negative 2. This time the output is 0.25 because 2 to the negative second power is going to be 1/2 to the second power, which is going to be 1/4, which is equal to 0.25. So now that we understand what the question is asking y'all, let's get into the fun part, the actual solution. And today I got 2 solutions for y'all. One, I'm going to give you the first solution. I'm going to break it down for you so we don't use anything that the compiler gives us. We're going to do the math ourselves. And then the second solution, I'll give you an easier, shorter solution where we can actually just let the compiler do the work for us. So first solution, let's get started. The first thing we need to do is we need to initialize x and n as mutable variables. And then, so in order to do that, we're just going to say var x equals x and var n equals n. Now we just are going to set the result. We're just going to set the result to 1, right? So we could say var res equals 1. We're going to give it a default value of 1. Now we need to check if the exponent n is negative, we need to convert x to its reciprocal, right? So to make n positive. So in order to do that, we just come right here and we say if n is less than 0, meaning if n is negative, what we're going to do, we're going to say x equals 1.0 divided by x. Then we're going to come right here, we're going to say n equals negative n. Excuse me, that should be a negative sign. Negative n, just like that. Now we need to perform our fast exponentiation using an iterative approach, right? That's my bad. That's a tough word. Exponentiation, right? And we're going to do that by squaring. So in order to do that, we're going to come right here. We're going to say while n is greater than 0, boom, we're going to say, first thing we need to do, we need to see if n is odd, then we need to multiply the current value of x with the result. So in order to do that, we're going to say if n mod 2 equals, or excuse me, exclamation point equals 0, which means it does not equal 0, we're going to open up the brackets. We're going to say res times equals x, just like that. Now we need to square the base to prepare for the next power reduction. So we're going to come underneath that and we are going to say x times equals x, and that's going to square it for us. Then we need to divide n by 2 to reduce the exponent. So in order to do that, we're going to say n divided or equal to 2. Boom. Then we're just going to come underneath this and we are going to say return res, and that will return the computed power of x, or of x to the nth power. So let's run this. Make sure it runs like it's supposed to. Let's see, y'all. Let's see. Should be that simple. It's accepted. So let's go ahead and submit it. Make sure it stays accepted after we submit it. We're not done yet. Look at that, y'all. 0 milliseconds beats 100% of users with Swift, y'all. Those are some good numbers right there. Those are the numbers I like to see. Now let's get ready for the second solution. The second solution, this was already an easy solution, but the second solution is even easier. Make sure y'all get one more look at the code before we get to that second solution. Make sure y'all got everything. That's the bottom half. That's the top half. Now let's start. Let's refresh this, start this over. Now for the second solution, y'all, guess what? Guess what? We got a one-liner. That's right, y'all. This solution real easy. The compiler is going to do all the work for us. We don't even have to do the math. We just have to plug in X and N to what the compiler gives us. So all we're going to do for this solution is we're going to say return pal, open up the parentheses, X, comma, then we're going to say double because N. We're going to make N a double. And that's all we have to do. This right here is, this pal right here is going to give us the, do the exponents for us, right? It's going to take X to the nth power for us. It's going to do that for us, compute that for us. We don't have to do anything else but run it. So let's run it. And it's accepted. So let's go ahead and submit it. Make sure it stays accepted. Let's see, and look at that, y'all. Same time, 0 milliseconds beats 100% of users with Swift, y'all. Those are some good numbers right there. That's what I like to see. So I hope y'all learned something today. Right now, we're in the math part of the top interview 150. So I hope y'all are paying attention, learning these calculations, learning these formulas, because this math part is going to be all about formulas unless we use something like this. But we're not always going to be able to use something like this because, as you can see in the previous question, they didn't want us to use something like this. But in this question, they didn't say anything about it. So I figured, why not throw this solution in there too? It's only one line of code, and it's not even that long. And so I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.